Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Ness. I am with Embedded Computing Design, and we are here today to talk about Wi-Fi. And my special guest for today is the guy who knows more about Wi-Fi than anybody I know. It would be Sivaram Trikutam, and he is the Senior Vice President of Wireless Products for Infineon Technologies. How you doing, Sivaram?
Hey, Rich, doing good. And great to be talking to you again.
Absolutely. So I put you up there pretty high, so don't let me down.
I'll do my best.
All right. So let's start from the beginning. Where are we with respect to Wi-Fi in general? And we'll probably start at Wi-Fi 7 because that's sort of the latest and greatest. What is the latest news with respect to Wi-Fi 7?
Sure. Okay. So Wi-Fi 7 is the latest standard that's shipping now. Just to take you a step back, right? As Wi-Fi evolved from Wi-Fi 1 to 5, the accent was all about increasing the data rate, trying to make the car go faster. From Wi-Fi 6, the industry realized that there's no point making the car go any faster if it's going to be stuck in traffic all the time. So the industry pivoted to trying to improve the efficiency of Wi-Fi. How do you use the spectrum better? So Wi-Fi 6 made a big step in that direction. 7 made an even bigger step in that direction. So that's the
Would you
latest technology.
quantify those that you're talking about when you say faster and what are the numbers associated with that?
Yeah, so the faster part, I mean, when you go from 1 to 6, 1 started at like 1 Mbps, and then 6 went up to nearly 10 Gbps, and now 7 can go up to 30 Gbps. But that's the peak speed, right? That's the speed when there's only one device connected to an access point. As more and more devices get connected to the access point, they kind of step over each other, and that's the efficiency problem I'm talking about. The effective data rate of the network drops. Wi-Fi 6 makes that significantly better. 7 takes it even further. So that's the latest in Wi-Fi technologies now.
Okay, excellent. I always feel like the semiconductor guys are a generation or two ahead of the OEMs. Where are the OEMs with respect to Wi-Fi 7?
Good question. And being in the semiconductor industry, we have to be 1 or 2 steps ahead of the OEMs because once we bring the new technology out, they adopt it. Um, in with respect to Wi-Fi 7, though the product started launching in about 23, so it's about 2 years now. Um, lot of the smartphone manufacturers, the laptop manufacturers, and the access point and router manufacturers, they've started moving to Wi-Fi 7. The rest of the industry is not yet started adopting Wi-Fi 7. And even in the access points and routers, today Wi-Fi 6 shipments are higher than Wi-Fi 7, but the rate of Wi-Fi 7 shipments is growing at a rapid rate. And we predict that by 2028, Wi-Fi 7 access points and routers will be this will cross or surpass the Wi-Fi 6 shipment. So they'll become the most popular technology in the infrastructure that's being created.
Won't we be shipping Wi-Fi 8 in that time frame?
Not quite. Maybe just the lead edge, but maybe it's more like 2028 is when we'll start seeing the first shipments of access points and routers. Then it's going to take another 3 to 4 years for that to build up to I mean to take over Wi-Fi 7.
Okay. One of the things that I've always learned is that there's always trade-offs associated with any new technology. So let's talk about what are the biggest benefits of Wi-Fi 7 and what are the challenges? I won't say downsides because I don't think there really are any, but what are the challenges that a developer faces when he's designing Wi-Fi 7? So you can start with either one, the benefits or the challenges.
Yeah, so if you look at the benefits, I mean, the single biggest thing that Wi-Fi 7 does is introduce a new technology called multi-link operation. So instead of having just one link, as you do with traditional Wi-Fi up until Wi-Fi 6, you can have multiple links at the same time between a device and the access point. Now, you could use that in two ways. You can either combine these multiple links. So think of it as the and. I can use link 1 and link 2 and link 3, or you could use it as link 1 or link 2 or link 3. Now, the first attribute that I mentioned, which is the and, which is combining the multiple links together, is what creates even higher data rate because you're using multiple links together and lower latency. And that's what you see most of the high-end devices today. I mean, I talked about the access points and routers, laptops, and smartphones. That's the version of Wi-Fi 7 they use. Now, naturally, that's a more complex way of implementing Wi-Fi. So the chips are more complex, the systems are more complex. I mean, the system components outside the Wi-Fi chip that's required to put the system together. So the power goes up, the thermal challenges go up, the cost of the system goes up. But of course, you get the benefit of higher data rate, and you also get the benefit of reduced latency in applications that need them. So that's on the
Okay,
one
let me
side.
interrupt you here because I got a whole bunch of questions. I'm going to forget them if I don't
Yeah,
ask them now.
sure.
How many links can you put together? And is it a direct um, benefit of bandwidth? If you put two links, you get double bandwidth.
Yes, you can put up to three links together, and it depends on the link. So if there are not all links are equal sized. So if you imagine two links are the same size, let's say an 80 megahertz link and another 80 megahertz link, you put those two together, you get roughly double the data rate. If you put an 80 megahertz and a 20 megahertz link together, you get maybe 20-30% higher. So it depends on the links, but to a first order, you're right. By combining them, it's an addition of
And
data
where
rate.
is that decision made? In the firmware of the transceiver?
It's negotiated between the router and the device. Now, of course, the device has to be capable first of doing
Mm-hmm.
this. So when a device connects, it tells the router, "Hey, I'm capable of doing this," and then the access point and the station negotiate to form a link of this sort.
Are we leaving a back door open here for security or issues?
This is nothing much to do with security. Security is a different topic. The multi-link operation does not in any way impact security. That's the same as before. But what I was telling you earlier is the and part is what I covered. Then the new stuff that's happening in Wi-Fi 7, that is the more recent stuff. In fact, Wi-Fi Alliance just announced a new certification program which is directed at multi-link for IoT devices. So the benefits of multi-link technology have so far been limited to the high-end devices that we talked about earlier. Now those benefits are going to come to IoT device. And by IoT devices, I mean the devices you and I regularly commonly use in our homes, the door locks, the thermostats, the appliances, and smart cameras, and the video doorbells, and so on. They could benefit a lot from Wi-Fi 7 technology too, but they can't afford the increase in the cost and system complexity that I talked about earlier. So there's another form of Wi-Fi 7, which is multi-link for IoT, where instead of using the links in an AND format, you use them in an OR format. So let's say you make three connections in 2 gig, 5 gig, and 6 gig. All three connections are alive, and you can dynamically switch between one or the other depending on the traffic conditions. So that increases to a first order reliability of these IoT devices. They can now operate at roughly 3x the reliability because instead of one link, you have three links with a similar system cost as what you had with Wi-Fi 6. And that's the exciting part about Wi-Fi 7 now, where it's going to expand into a broader ecosystem of IoT devices.
So I assume in that discussion, something like a smart lock would be at the lower end because it's just pinging very infrequently.
Exactly. So the devices like smart locks and security cameras and so on, they are used infrequently, like you said. But when you want to use them, I mean, the 5 or 10 times that you want to use them, you want them working. You don't want them disconnected just when you want to use them. So these are what I call always connected devices. So they have to be connected 24 by 7, although they are actually used only once in a while, right? So reliability of network connections is very important for such devices. And Wi-Fi 7 with the multi-link for IoT technology I talked about earlier does exactly that. It improves the reliability of Wi-Fi connections for these products.
So let me go out into left field and tell me if this makes no sense. I think of what you just described as an application for something like LoRaWAN, where you're not really concerned with the bandwidth, but you're very concerned with the power, and that would consume very little power. Is it possible to do a multi modal part that would use LoRaWAN to say, okay, I need to be turned on now, and then it jumps over to Wi-Fi for a faster transaction?
Yeah, I mean, generally these two don't intersect though. I mean, Wi-Fi is more in the home. I mean, if a device is operating in an area where Wi-Fi is available, that's the best technology to use. It's areas where the Wi-Fi is not available, outdoors, remote areas, agricultural farms, I mean logistics and asset tracking in certain areas. That's where a technology like LoRaWAN might have benefits over Wi-Fi. But where Wi-Fi is available in a shopping mall, in an
Hmm.
office environment, a sports stadium, a home, and so on, nothing beats Wi-Fi, right, in terms of as a connectivity technology.
Okay. And um, is the range the same as it always was, or does this extend the range? Does it shorten the range?
The range benefits actually come from Wi-Fi 6, the improvements that happened in Wi-Fi 6, and those carry forward into Wi-Fi 7. Um, Now, of course, there is more power benefits that come here. But, actually, Wi-Fi 6 made a big step forward in terms of improving power for devices that are used infrequently, sensors and so on and so forth. Wi-Fi 7 takes that a step further by improving those techniques. So you get even better power savings when you go from 6 to 7.
Can you quantify that and dive down a little more on how the power savings comes to be and what a developer needs to do to realize that power savings?
Yeah, so those, I mean, it depends on the use case. So the simple concept that Wi-Fi 6 introduced is something called TWT, target wake time. That is, you're not limited by the access point's ability to keep your connection. That you have to keep waking up periodically and keep telling the access point, hey, I'm still here, don't drop me off of the network. So Wi-Fi 6 extended that period. So now you could sleep for even minutes without having to ping the access point, and the access point won't drop you. So those techniques have got refined in Wi-Fi 7. So depending on the use case, the way you implement them, you could get anywhere from 10 to 50% benefit in the power. But what's also happening is the semiconductor industry is also responding. The standards aside, 6 to 7 improvement aside, the chips are getting better too. They're being implemented in the latest silicon technologies. The architectures are evolving, and these are particularly tailored for devices I mentioned earlier, the always connected ones, but used infrequently. A lot of those are turn out to be battery operated devices. So the battery life is very important. So the industry is responding by developing lower power products. Like for instance, we do a product which can stay connected at 70 microwatts. That's like crazy low. I mean, 5 years ago, nobody would have thought that you could maintain a Wi-Fi connection at anything under 100 microwatts, and we are at 70 microwatts. So that's the level the industry is moving to.
Uh, okay. Finally, more specifically, what is Infineon doing? You
So
alluded to it. Let's.
yeah. So Infineon, I mean, we are an IoT focused company, so we work very closely with the Wi-Fi Alliance. The new addition to the Wi-Fi 7 I mean certification program that we just talked about. We've been working very closely along with some of the other industry partners in making that a reality to bring the benefits of Wi-Fi 7 to the world of IoT. And we've got that done now. Now, from a product standpoint, we've also introduced a product which is basically addressing this specific use case that I talked about, Wi-Fi 7 for IoT products. So it can do the multi-link for IoT, that is multiple links active at the same time, but using only one when you need to. So we have a product which will be the world's first, industry's first Wi-Fi 7 IoT product that's just announced. Very low power, 70 microwatts, ideally suited for battery operated devices. So Infineon is pursuing making Wi-Fi connectivity for these types of battery operated IoT devices ubiquitous, and we want the industry to move in that direction. So our products are basically designed to help that cause.
That is awesome. Thank you very much, and congratulations on that. That's some achievement.
Thank you, thank you. We're really proud of that, and we are excited to bring this. I mean, we call the product 741X. By the way, we are really excited to bring this product to the market, and can't wait to see what our customers will do with it and improve the experience of using IoT devices.
Same here. I'm looking forward to it as well.
Thank you very much.
That was Sivaram Trikutam. He is the Senior Vice President of Wireless Products for Infineon Technologies, and I am Rich Nass with Embedded Computing Design.